Hello grade 10 students. Welcome to another virtual class. I am Miss Madhu. In today's video lesson, we will perform an activity to verify Pythagoras theorem geometrically by using the method of paper cutting and pasting. This is activity number 4 according to the PDF that I have shared for the write-up of maths activities. Those students who have not written the activities yet can start writing with this activity and number it as 1. Also, it has come to my notice that some students do not have journals to write down the activities. So if you have not yet bought any journal and you are unable to get it from the school store, then you can buy a journal from the local shop that has ruled page on the right side and plain page on the left side. So the aim of this activity is to verify Pythagoras theorem by performing an activity hands-on. To do this activity, we will require some material. We will need 8 marble papers of 4 different colors. That means 2 marble papers of each color. So 4 into 2, that makes 8 marble papers. Then we will need pair of scissors, glue, geometry box, and of course you will perform this activity in your journal. To be able to perform this activity accurately, you need to have some previous knowledge. Number 1, you need to know the statement of Pythagoras theorem. It states that in a right triangle, the square of hypotenuse is equal to the sum of squares of other two sides. And that is what we are going to verify. Number 2, you should know the concept of right-angled triangle, that a triangle in which one angle is 90 degrees is called as right-angled triangle, and the side opposite to the 90-degree angle is called as hypotenuse. Third, you must know that the area of square is side into side, and you should also know how to construct perpendicular lines, right triangle and a square. This activity will have 2 parts, that is design and conduct. For design, you will prepare your cutouts of the figures, and for the conduct, you will use these cutouts to verify the Pythagoras theorem. The first step of this activity is to cut a right triangle that is right angled at C using a marble paper. The sides of this right triangle will be 2.5 inch, 2 inch and 1.5 inch. Why we are working in inches? Because if we work with centimeters, the triangle will become too small and the figures will become too small to get any kind of accuracy. Then you have to cut 2 identical squares using same color of side 2 inches. Then we need to cut 2 identical squares using another color with side 1.5 inches. Then cut 2 identical squares of same color with side 2.5 inches. So this square that I have taken is 2.5 inches. So we need only one cutout of this triangle, and we need 2 identical cutouts of square with side 2 inches, 2 identical cutouts of square of side 1.5 inches and 2 identical cutouts of square of side 2.5 inches. Now one cutout from each of these squares will be used for conduct and one cutout will be used for design. Now you will take each of these cutouts and place the triangle in the center of the page, and you are going to place each of these squares along the sides of the right triangle. Notice that the sides of these squares are equal to the sides of right triangle. So the squares should perfectly align along the sides of the triangle. So the 2 inches square will come here, 1.5 inches square will come here, and 2.5 inches square will come here. So all these cutouts are to be pasted in this manner on the plain side of the journal, and you will give the heading as design. And then you will label the figure. The big square will be labeled as ABFG. The small square you will label as AHIC, and the middle square will be labeled as BCDE. Also, you have to mark the sides of the triangle. So this is 2.5 inches, this is 2 inches, and this is 1.5 inch. Now the next step is to extend FB using your ruler and pencil so that it meets ED at P. See that this line is dotted in your journal. I do not have an option of dotted line, so I have to manage with this. But make sure that this line is dotted in your design. Next, you will extend GA using your ruler and pencil such that it meets CI at Q. Then using a protractor, you will draw a perpendicular line from P that cuts CD at R. See that angle BPR is perfectly 90 degrees. Otherwise, you will have problems in aligning your figures in conduct. Now we have completed the design of this activity. So observe that we have divided the green square into 2 parts and the orange square into 3 parts. So we are going to number these squares as 1, 2, 3, 4 and 5. All this has to be done on the cutouts that you have pasted for design. So the next step is to obtain these parts 1, 2, 3, 4 and 5. We have identical cutouts of orange square and green square. So what we are going to do is superimpose those cutouts on these squares, and then we will take these points B, P and R on the identical replica of square with side 2 inches, and we will get points A and Q on the identical replica of square of side 1.5 inches. After getting these points B, P, R, A and Q, you are going to join B to P and P to R, and you will join AQ. And then you will cut along BP, PR and AQ to get 5 parts. Now we will need the identical cutout of the big square, that is of side 2.5 inches, and these 5 cutouts for the conduct. Now what we have to do is arrange these cutouts on the big square to cover it completely. I will start with the biggest piece. You may have to rotate and flip these figures. This triangle will fit over here. This piece will come here. And this triangle will fit here. And the small triangle will fit over here. So this is what you are going to paste under conduct. So you will paste the biggest square on the plain side of the journal, and then you will fit these 5 pieces onto it. So what observation can we make from this activity? The cut pieces 1, 2, 3, 4 and 5 of the smallest square and the middle square completely fits on the biggest square. This means that area of these two squares is equal to the area of the big square. The side of the smallest square is AC, so its area will be AC square. The side of middle square is BC, so we can write its area as BC square. And the side of the largest square is AB, so its area will be AB square. So since these two squares fit onto the largest square, it means that the sum of areas of these two squares is equal to the big square, and we can write it as AC square plus BC square equal to AB square. But AB is the hypotenuse of the right triangle, and BC and AC are the other two sides. So we have shown that the square of hypotenuse is equal to the sum of squares of other two sides. This is the stepwise procedure that we have followed to perform this activity. Over here you will make one small change and write here one identical right triangle ACB. Make sure that the labeling of your figures is according to the procedure. These are the steps of observation which explains how we have verified Pythagoras theorem using geometric figures and their areas. So we can conclude now that in a right triangle, the square of hypotenuse is equal to the sum of squares of other two sides. With this, we come to the end of this video lesson. See you in the next class. Until then, goodbye.